Welcome back. I'm pretty sure it's been a while for most of you, but we ran into some technical difficulties. But here are the last three videos of the 2014-2015 school year. In this one, I'm going to recap the finale of the fourth 6 weeks, and in the following videos, right after this one, you'll be seeing pretty much the ending of the school year, right before we started reviewing for STAR and finals and whatnot. Let's begin with the vocabulary. Words you saw included adjacent angles, vertical angles, supplementary angles, complementary angles, straight angles, congruent angles, acute triangle, right triangle, obtuse triangle, and scalene triangle. And there's a few more coming up. But while I give you a chance to kind of observe these, make sure you go back to your notes and look up the definitions for each of these, because I'm not going to be going in too much depth, just a bit of a brief recap of everything that you've done that 6 weeks. So make sure that you look through all your definitions and use your resources that I've given you throughout the school year. That way, if you happen to forget a definition, you happen to have them there. Plus, the textbook is available online, so make sure you log in and look for that as well. Other words included isosceles triangle, equilateral triangle, equiangular triangle, rectangle, area, formula, square, parallelogram, rhombus, and base. And there's just a few more coming up. And of course, at any point during this video, make sure that you pause if you need to stop and kind of take a glance at some of the vocabulary or formulas or examples. This is all geared towards you, towards your comfort, towards your pace. So if you ever need to pause, fast forward, rewind, anything you need to do, by all means do that. The goal is to help you. Moving on, we also had height, trapezoid, three-dimensional figure, prism, rectangular prism, volume, and cubic units. This particular 6 weeks was loaded with vocabulary terms that you learned. So, like I said, it would really be in your best interest to go back and just review them a bit. Make sure you understand what each one is and what you need them for, or what sort of context they'll be used in the STAR. As far as the lessons in the second half, something you saw was angles, and we talked about adjacent angles, which are angles that are side by side. They share a vertex and a side, if you think about it that way. And then we also had vertical angles. If you look at vertical angles, you'll notice it's when you have two lines that intersect and the angles that are above each other. For example, angle 1 and angle 3 are vertical angles because they're right above each other. Or angles 2 and 4, those would be considered vertical angles. So if they share a vertex and a side, they're adjacent. If they're on top of each other, vertical angles, or side by side. We also had supplementary and complementary angles. With supplementary, what you have to think about is, think of it kind of like supplements. Like when a bodybuilder takes supplements, vitamins, it makes you stronger. In this case, think of it as a couple of angles, taking their vitamins, getting nice and big into a 180-degree angle. So when you add them up, it's a 180. Another way, and you might need to go back to your notes, you can turn that S into an 8 and the U into an O, like a 180. Complementary, draw a big line right across that C and it becomes a 9, like a 90. Because complementary, they form a 90-degree angle. Now, as far as straight angles are concerned, the one thing you have to remember there is that, if you think about it, angles that are forming a straight line are straight angles, and the measurement of those will always be 180. Two angles that are supplementary form a straight angle. So if you look very carefully at that picture, those first two angles form 180. They form a straight line when you put them together. When two angles have the same measurement, they're called congruent angles. And you'll be seeing that when we get to triangle. Now let's practice a little bit. If you look at that first example, first of all, these two angles are sharing a side and a vertex, which makes them adjacent, correct? Now, if you add them up, they add up to 90 degrees, which also makes them complementary. So they are adjacent and complementary. Look at the next example. If you were to add those together, it gives you 180, which is a straight angle. And anything that adds up to 180, don't forget, they are supplementary. They are not sharing a side and a vertex, and they are not one on top of each other like a vertical angle, so they're just simply supplementary. In these examples, if you notice, look at that first one. Combining those two, you get a straight angle, which equals 180. So in order to find one of your missing angles, you would do 180 minus whatever angle is given. Whatever your answer is, that's your missing angle. In this case, it's 62 degrees. In the other example, it has to add up to 90, and we know that one of them is 36. So if you subtract 90 and 36, you find 54 degrees. You find your missing angle. So whenever this happens, if you're missing an angle, just think, do they add up to 90 or 180? And subtract. As simple as that. As far as triangles, acute triangles, all angles are acute. Right triangles, they have to have one right angle, just one. Obtuse triangles have to have one obtuse angle. That would be for the interior of a triangle. If we look at the exterior, if all sides are a different size, then it is scalene. If two sides are the same, that's what those two little tick marks are on there. If two sides are congruent, you've got isosceles. Think of those two S's as same, same. And that O could be like other, another measurement. Equilateral has that word, it's not spelled the same, but it sounds like it, equal. It means all three sides are equal. And those tick marks mean everything that has the exact same tick mark is congruent to each other, or are congruent to each other. So let's go a bit more into triangles. Look at these examples right here. If I wanted to classify them, you would look at the triangle's interior and exterior. If you look at the first one, it has a right angle, so it's a right triangle. If you look at the exterior, no sides are equal. They're not congruent, so it is a right triangle and scalene. Second one, the interior are all acute. The exterior is all congruent. Are all congruent, so you have a acute equilateral triangle. Again, as long as you can identify the different parts, it's real simple to name. And it's always good to know this, so make sure you study. Now, as far as the relationship of the different sides and angles of an isosceles triangle, let's take a look at it. If you look at side LM and MN or NM, if you look at them carefully, it tells you they're congruent. Well, guess what? Because of the exterior, it affects the interior. So if those two sides are congruent, the angles on the bottom part of the triangle are also congruent. It's kind of like they correspond to each other, like opposite sides. Like MN is related to angle L. LM is related to angle N. They're on opposite sides of each other, but that's how they're related. Any idea what angle M would be connected to or related to? LN. Again, it's just a quick review. Make sure you look through your notes, your reviews, and so on, this is just to supplement all that. It's just a quick recap so you could say, oh, I remember seeing that. At least let's hope you do, right? Triangle inequalities. You cannot just have a triangle with just random measurements. One thing that's very crucial has to happen. If you add up two sides, they have to be greater than the third side. If I were to add up A and B, has to be greater than C. A and C has to be greater than B. If I were to add B and C, that answer also has to be greater than A. If all of those are true, you've got yourself a triangle. If one of those is false, just one of them, it's not technically a triangle. It can look like one, but if the measurements are inaccurate, it doesn't count. It's just not a triangle. Simple as that. So always give that test. Give triangles that little test. Check if two sides are greater than the third and go all the way around and try it out. That's very crucial because I have a feeling they might try to trick you on the star, giving you measurements and asking you, is this a triangle? So always remember, add up. Two sides have to be greater than the third. So take a few seconds, absorb what you see there, just kind of give it some time. Pause if you need to, like I said. And look through your notes. Supplement everything because star is always right around the corner, right? As far as rectangles, those four-sided figures, the area of a rectangle, in other words, the inside, like how much space is it covering? In order to calculate that, one way would be to use the formula, length times width. And again, when you're calculating the area, when you're finding the length times the width, you're pretty much finding out how many square units cover that surface. If you were to cut it into a certain number of squares, that's your area. So if your length is 4, cut it into 4 columns. If your width is 2, cut it into 2 rows. If you can picture what I'm describing to you, you've got yourself 8 squares. If you were to use the formula, 4 times 2, 8. And again, make sure you look at the word formula. It's pretty much an equation that helps you solve something. Now we've got parallelograms. Parallelograms, what happened was if you got a rectangle and you were to cut a little triangle off of it and move it to the side, that's a parallelogram, pretty much. And that's actually how they created the formula. Because the height of that triangle that you cut and the base of that parallelogram, it's very, very similar to the length and the width of a rectangle. So even though it sounds different, base times height, it's the same idea. You're multiplying those two measurements to get your area. And just take some time to look at that and just, use your imagination. Picture that little empty space right there in that rectangle, that little triangle on the side, being filled in by that triangle that they cut out. That's how we got that parallelogram. And then we've got area of triangles. Picture a parallelogram like the one you see right there. If I were to cut it into 2 triangles, can you all see that? Well, think about it. What's the formula for a parallelogram? Base times height. Well, if you do base times height, it's almost like you're finding the area of 2 triangles. So how do I find the area of 1? Cut that answer in half. And that's how you get your formula. 1/2 of the base times the height. Or if the sight of that 1/2 kind of scares you, look at it another way. Think of it as base times height divided by 2. And always be on the lookout. They're always on standardized tests and certain homeworks and lessons and whatnot. They'll always give you enough data to fill in the blanks with these formulas. Now trapezoids, that formula can look kind of scary, but it's real simple. If you look at a trapezoid, it's almost like they got a really long parallelogram and cut it right down the middle with a diagonal line. And what do you have? 2 trapezoids. So it's almost like finding the area of a parallelogram, cutting it in half diagonally, and getting a trapezoid. But the formula is a bit more complicated than that. So let me give you my interpretation. Pretty much what you would do, add the top and the bottom, your bases, multiply by the height, cut that in half, and you've got yourself the area of a trapezoid. So base plus base times height divided by 2. Sounds scary, but don't worry. Use your reference material, that chart that'll be provided for you on the test, to kind of refer to this formula, so it shouldn't be a problem. With volume, the main emphasis this school year was volume of rectangular prisms. If you were to look at those, it's slightly different because your units are cubic units. In other words, how many cubes can I cut out of this three-dimensional figure, not squares like area. For volume of rectangular prisms, it's as simple as length times width times heights. And don't let that big B scare you. It just means find the area of the bottom, the base, which would be length times width. So, now that this quick review is over, just make sure you prepare yourselves mentally, because next up is mean, median, and mode, measures of spread, dot plots, stem and leaf, histograms, box plots, shape of data distribution. And the video after that is going to talk about the financial side of things. So stay tuned. It's coming up right away, and keep on studying. Good luck.